Good evening, everyone. Welcome to Network Seminar Series hosted by the Center for Networked Intelligence at the ECE and RBC CPS IISc. It's my pleasure to introduce today's speaker, Professor Danish Pruthi. He will be speaking on detecting AI slop in research and beyond. Danish Pruthi is an assistant professor here at IISc. He received his PhD from the School of Computer Science at Carnegie Mellon University. He is broadly interested in the areas of natural language processing and deep learning, with a focus towards inclusive development and evaluation of AI models. He completed his bachelor's degree in computer science from BITS Pilani. He is also recipient of Schmidt Sciences AI 2050 Early Career Fellowship, Siebel Scholarship, CMU Presidential Fellowship, ACL Outstanding Paper Award, and industry awards from Google, MSR, and Adobe. Until recently, his legal name was only Danish, an edge case for many deployed NLP systems, leading to airport quagmires and in equal parts funny anecdotes. Over to you, Professor.
Yeah, thanks for the kind invitation and introducing me. I know it takes a lot of work to set these things up. Just a quick check. Can people on Zoom hear me? Can someone just, okay, perfect. So feel free to interrupt me at any point of time and ask questions. I would rather prefer it that way rather than you not understanding anything and holding on to your questions till the end. So, oops. Okay, let's see. Okay, yeah, sorry. So I broadly work in this area of natural language processing, which is the science and engineering of building models that can handle human text. And we are concerned with tasks like text classification, machine translation. Okay, sure. 1 second. Okay, got it. Hey, 1 second. How should I, where is this option to? Okay, perfect. Okay, is it okay now? Can people hear it? Yeah, okay, perfect. So yeah, I was just broadly introducing the area I work in. 1 sec, this needs some more work, yeah. Yeah, so, okay. Yeah, so the kind of problems we concern ourselves with are, let's say, you want to identify a sentiment of a piece of text. Maybe you're a CEO of a company, you want to track the pulse of that company on Twitter or social media, understand the sentiment. Like in world, we have 7,000 plus languages. We want to be able to understand people who don't speak our language. So machine translation is obviously super important. And we are curious beings. We want to ask questions and we want answers. And language technologies have already impacted your life, whether you realize it or not. So if you are searching for something on the internet, or you're using ChatGPT, or translating, or if you're typing on WhatsApp or Gmail, it completes stuff for you. These are all NLP systems behind the scenes. And mostly language models behind the scenes. So language models are nothing but models that assign probabilities to sequences. These are sequences of words. So for instance, a model can take in a sentence and assign a probability to it. So it can also look at what are possible next words that could come and tell you which one is the most likely to come, because it can assign probabilities to all possible words. So if you say things like, I'm sorry for the inconvenience, the model will likely autocomplete it to cost. I'll get back to you sometime soon or sometime today. I work at IISc, I live in Bangalore. So as you can see, if you train these kinds of systems on lots and lots of data, it starts to know information that maybe IISc is in Bangalore, or the Prime Minister of India is Narendra Modi, and so on. And these language models do a lot more than just memorizing information. They can now do a whole host of tasks. So this is a graph from a paper by OpenAI, and we're only looking at, let's say, GPT 3.5 and 4. So the percentile is on the y-axis. So the median human performance is 50 percentile. And these are some popular benchmarks like bar exam, SAT, GRE. Many of you might have taken them, or at least the IIT JEE might be more familiar here. And these models are GPT-4, which is better than 50% median, and does remarkably well on exams that we consider very tough, like IIT JEE. This is also on the exam that was not publicly released. So this is really a held out copy. And this is like, again, remarkable non-trivial amount of performance. So these models are quite good. They are better than 85% of the exam takers. Still won't make it to IITs. IITs are more competitive than that, but they're getting better and better. So there's clearly a lot of promise of LLMs. We all are scientists, so we want to see them advance science. There are some key examples for doing that, like similar technologies have been used to, let's say, help with AlphaFold and other efforts. And there's generally a lot of promise around LLMs for X, LLMs for science, or AI for science. And everybody is also at the same time curious, how will AI impact their jobs? So as scientists, we should also ask, how much can LLMs automate science and research, whether I would still be in my job 10 years from now. Some papers like this suggest that the answer might be no. This paper by Sakana Labs claims that they built an AI scientist that gets you towards fully automated, open-ended scientific discovery. And again, these are like bunch of popular, credible authors who have written this up. This is a startup called Sakana AI Labs based out of Japan, and it's a highly well-funded startup. They've, I think, raised $200 million and so on. They're building these AI scientists. And there is another company called Intology, which is built an agent called Zochi. And Zochi has been able to produce papers. So right from generating ideas all the way till giving you a LaTeX templated output, a PDF that you can just go and submit to a workshop or a conference. These systems do that for you. And in fact, this one even got you an acceptance. So this is like, ACL is the prime venue for people like me. And just this year, they had a submission which got accepted. Maybe the skeptics here might say that this is more to do with the quality of reviewing rather than contributions by this paper. But believe it or not, these systems can generate realistic, plausible looking scientific articles. So there's a lot of that. In fact, the AI scientist paper that I was talking about earlier, they also generated an article, submitted to an ICLR workshop, and got good enough scores that it would have been accepted. They withdrew the paper because it was automatically generated, but the scores were good enough for it to be accepted to an ICLR workshop. And this is like main conference. And they say that this marks a watershed moment. This is similar to maybe 2 years of PhD grind. So they're calling this like PhD level intelligence. DeepMind, Google has a similar paper towards an AI co-scientist. So we still have a job, this co-scientist. But again, like you're seeing, there's a lot of optimism around it. And if I were to just give you a conceptual illustration of what AI scientists look like, they do everything from idea generation to checking whether it's novel, whether people have done this in the past, also figuring out which ideas are good, which are bad. So that role your advisor does is now being done by these models. After the ideas are scored, they're deciding which ideas should we actually implement over a code base. So it's connected to an agent that can actually write code. So think of this as like a cursor-like agent that's writing code over a repository of a baseline approach. And it is then interpreting the results of the experiments. And based on how the results look like, it is also able to update the plan, conduct new experiments. And whenever it feels like, look, this is positive, this is good progress, now I can go write a manuscript. So it does everything by itself. And towards the end, there is also an LLM paper reviewer. So the reviewer's job is also now taken care of. The reviewer is also giving you feedback about the quality of the idea, about the experiment, about the rigor, and so on. And you keep doing this until you find really good papers. And again, like this is not one LLM call. There are like hundreds and thousands of LLM calls that go into generating a paper. So it is it's a sophisticated system. It's not just asking ChatGPT, give me a paper that will be accepted to NeurIPS, right? So it's more complicated than that, but like a lot of individual pieces, but mostly LLM powered. And I think like one of the exciting phases is ideas, because this is where it all starts. There was a recent Stanford study which asked this obvious questions, like can LLMs generate novel research ideas? And they find the answer is surprisingly yes. So this is a statistically significant result where the AI answers or AI ideas are more novel than human generated ideas as per their study. They take ideas from experts like you and LLMs, shuffle them and send it to a different set of experts who don't even know whether they came from, let's say, you or an LLM. So they are just giving you ratings on novelty, excitement, effectiveness. And this is again like a very popular paper last time published at ICLR. And the two key results are LLM generated ideas are more novel, more exciting, statistically significant. But other effects are not statistically significant. But excitement and novelty are. So again, like this is surprising and an important result. So one of my students thought, wow, like these systems exist. I want to apply for PhD applications. I should, up my productivity, do more work, figure out what are all the amazing novel ideas that we are missing on, ideas that my advisor is not sharing with me. So he went to the system, looked at some of the ideas that were generated, and was quite spooked by looking at an idea. It was very similar to a paper he had read. So that caused him some anxiety and worry, and he felt like, something's off. So he thought he'll generate more ideas, and in a few more examples, he realized that some of the ideas that were proposed by these systems looked very similar to ideas he had actually read in existing published work. So he thought he can actually do this a bit more systematically. And while the prior work assesses novelty through shuffling human ideas and AI ideas and giving it to a random set of experts, when we do that, we are kind of assuming nobody's trying to actively cheat and plagiarize. So when you send a paper for reviewing, you assume, or maybe the reviewers assume good faith that you might have missed a related idea, but you're not actively trying to cheat the system. I don't think those assumptions should apply to AI agents. So because my student was very curious and he felt that there might be some amount of plagiarism going on, he changed the situational logic, and instead of asking experts, is this novel or not, his question was, can you identify the most closely related work to this paper? And he requested people to presume plagiarism. Assume that there is plagiarism. Can you find it? If you can't find it, that's okay. And but we want to give people a chance that there might be plagiarism. So why don't you actually look for papers that are closely related? So they were asked to actively search for overlap in methodology in existing work. So we took a lot of proposals that were generated from the Stanford study and some papers from the AI scientist, from their own exemplars that they have highlighted in their papers. And we found experts in these areas, like we had 12 or so experts, and these are the topics of papers that we generated. And we asked people that, can you tell us whether this idea is a direct copy? Like, is it copying one-to-one from an existing published work? Or is this borrowing, mixing, and matching work from 2 or 3 papers? Or there is some overlap, but that's partial or minor, or this is actually original. And in 4 and 5, I think they are quite problematic cases, because both 4 and 5 don't acknowledge or credit the past work. So this is combined borrowing. Even if they might be taking your method and clubbing it with a data set that you released, they're not citing any of you. So there's no acknowledgement to the work that you've done. So both 4 and 5 are problematic, which we assume are plagiarized. So the key result of our study, which we conducted by 13 experts from 5 universities, 2 labs across, I think, 3 continents, one of the alarming results was a large number of proposals were plagiarized. About a quarter of them were plagiarized. And also remember that the large system of AI scientists also has inbuilt plagiarism detection. So anything that looks obviously similar to something that's published is already caught and weeded out. So this is all the papers that are bypassing the inbuilt plagiarism checkers. And when, let's say, some expert like you highlighted that, okay, this is the paper that is a score of 5, it directly copies from, let's say, Parimal's past work. We went the extra step and emailed source authors like Parimal that, do you agree or disagree with this accusation that this is plagiarizing your work? So we've done the due diligence to actually double check whether the work is actually score 5, score 4, or so on. So 24% of the cases are actual verified cases. So you should see this as a lower bound. The actual numbers might be much higher, right? And the nature of plagiarism is quite sophisticated. It's not like verbatim copying. It is like skillful rewording. The model might introduce like a new terminology altogether, might say, oh, I have introduced resonance graph. And you look at all the steps of that or all the notations and you realize, oh, wow, this is adjacency matrix. We know what it is. This is what we call it, right? So it's like the models were asked to generate novel ideas. They're satisfying those requests by, really skillfully rewording existing terms. But at the core, many of these ideas are exactly one-on-one matching with existing work or are heavily borrowing from 1 or 2 papers. There are lots of other case studies in the paper. So one natural question to ask might be like, can we detect this plagiarism automatically? So we had only 13 experts and we had already tortured them enough with the study. So we thought, can we scale it up and can we do a automated version of this study where we check whether automated plagiarism detectors work at all? So we synthetically generated a data set of plagiarized papers. So we asked GPT-4o and Claude that here is a paper, I want you to plagiarize it. Generate me a copy that is exactly this paper. You may paraphrase it, reword it, and try to not get detected. Okay. So Claude did not obey the request, said like, can't do it, not safe. GPT-4o generated lots of papers that were plagiarizing the existing paper. So now we have a benchmark of papers and a plagiarized version of that that's plagiarized through GPT-4o. So now we can ask, okay, how well do detectors do? Can detectors identify this? First things first, the detectors that we are used to detecting plagiarism like Turnitin, OpenScholar, they don't work at all, right? Like 0%, because this is like very, very skillful paraphrasing, rephrasing. So whatever we traditionally know is just not working at all. If we give Claude and GPT-4 the exact paper that we plagiarized from and ask, can you tell me whether it's plagiarized from this paper or not? Models say with 88 and 89% of the times, yes. So if they have the right paper, they can more or less tell. But if you just ask the model without this Oracle paper, like Claude just gives you 1.3% accuracy. GPT-4o is slightly better, but that might also be because we have generated papers from GPT-4o. But still, remember that none of this is good enough to actually use in an academic system. Like IISc can't adopt this, for instance, right? Then half of the papers, only 1/3 of the papers are being caught. And if you allow these systems to also do retrieval, if these systems can also look up semantic scholar and the web, then the performance is slightly better, but again, not good enough. And retrieval really is the bottleneck here, right? As you can see, if it has the right paper, it's able to match and tell you that, yes, it looks maybe plagiarized. But without that paper, it's very, very hard for these models. So a natural question to maybe follow up is like, what about humans? Maybe we also plagiarize. Maybe our conferences are also filled with plagiarized work. Again, we had 13 annotators or experts who we had already tortured enough. So we don't have experts anymore. But remember, peer review is a process where experts give feedback to other experts. So we thought that since we don't have any more experts, we can at least look at past reviews and identify that, are there signs of plagiarism? Are there complaints in those reviews that sound like plagiarism, sound like score of 4 and 5? So this is not using an LLM to decide whether there's plagiarism. It's looking at a peer review provided by a human being to understand whether there are signs of plagiarism in it or not. And this is some of the conferences we tested it for, but the rates of score 5 are very, very low. So humans are not plagiarizing, but models do, right? So the broader implications of this work are that models might be regenerating old ideas, calling them as novel, and they're not attributing any of that to people who did the work. And our conferences, AI conferences, are currently overwhelmed already. So you can imagine the impact these AI scientists might have on the existing reviewing infrastructure. And overall, I feel like this could also fracture scientific discourse. Right now, we are only talking about novelty. That's one aspect of science. We want to ideally be able to track who, whose ideas are these, who came up with this first, and that's been important for science. But other important things like correctness, like is this even correct? A lot of these things are still being researched. So this could actually have massive, massive implications on scientific discourse. And I think broader claims or general bolder claims about AI scientists or co-scientists might even saw, some like it might say that, even people might feel that other AI capabilities are not legitimate. So it might sow distrust in other capabilities, which I think is also an important implication. So this study was published in ACL this year. This is like mostly work envisioned, discovered, led by my student Tarun. And some early impact of this paper received the Outstanding Paper Award in the conference, because I think we highlighted how this was a big problem. And there's currently a huge wave of optimism around AI producing science. This paper was also covered in a Nature News feature, which came out just last month. And this is written by Ananya. I suggest you take a look. She also is collecting a lot of input from a lot of scholars on what counts as plagiarism. And I think the TLDR is it's very hard to detect plagiarism or even stake claims about plagiarism, which I think some of the educators here might know. So broadly, if we were to step back, this is not just maybe happening in research. People have coined this term called AI slop, which is often used to demarcate low quality, nonsensical or misleading content generated by AI. So I'm sure at some points of time you have seen AI slop. There's some nice articles about how it is distorting our reality, how it is slowly killing the internet. And thanks to these systems, there are like increasing reports of plagiarism, right? Like lots of students were found cheating by this UK university. And I think anybody who has taught a class last year will, confirm these allegations, right? Like people have seen a lot of abuse of these systems. So there's a lot of content that's generated uh, by these systems that is meant to do homeworks. In fact, it's not a secret anymore that OpenAI and other model usage peaks in May. Like you can imagine why, right? Uh, and like this happens to be one of the most important or one of the most used cases. And again, like given these models, it's also very easy to generate targeted misinformation. So if we know that you are at IISc, you believe in science, I want to convince you to vote for BJP, let's say, I can generate a very misinformed article about how maybe the party is supporting science, even though it might not be, right? So it's very easy to generate targeted misinformation. Yeah. And people are worried about this, like naturally. So there's a clear need to distinguish LLM outputs from human text. Right? So I think to abstract out, we want to ideally be able to distinguish LLM output from human text. Lots of use cases. Another use case that might be a bit counterintuitive is, let's say Gemini is doing another run of its own training. It wants to collect all the new data, new events that has happened since the last batch of training. It does not want to train or retrain on LLM outputs. So even Google would be happy if I could offer them a detector that works, for instance, right? They don't want to train on, let's say, OpenAI content. because of whatever, let's say copyright issues, so on. So there are lots of reasons to be able to, there are lots of motivations to distinguish LLM outputs from human text. So any questions so far, by the way? Yeah. Sure. So I'll come to that. Watermarking is a part of the solution. Yes. Any more questions? So like you're making a statement that we don't have systems. We don't have extremely robust systems, but some systems are better than others, and I'll tell you about them soon. So they are coping with all of this. So they are also figuring out which detectors work. I think they are less worried about fully AI generated papers. They are more worried about AI generated reviews for now, because people are also reviewing through these models, right? Surprise, surprise. Okay, any more questions? So people who are viewing this on Zoom, also feel free to unmute at any given point of time and ask questions if there are any. So, okay, so I think like hopefully the problem is motivated, people are with me, they understand we need this. So there's some possible approaches to do this, right? One approach is you might get lucky. You might receive emails like this, right? So I got an email for someone who was impressed by work carried out by local lab, which is not my lab, Aditya's lab. And the email said, you know, you should mention a specific project or aspect about the lab's work that interests you, right? So this is like a student who's like off by a few points, right? Like not my lab and still the email is not filled. Clearly, like I got lucky here. I was able to detect this is AI written. Sometimes even funnier things happen. This is a student who emailed me, and a part of the conversation he's having with an AI model is also a part of it. So the model says, it looks like you've applied for a position, a research internship, and you've already received a response, but you might still want to send a follow-up, and here is a refined response you could use. Right? So, I mean, like, people send me this, and these are not cherry-picked examples. Like, every month I get one such email. So, I mean, this is a reality. I mean, I think a lot of people here might find this amusing, but this is a reality. Sure. So the Oracle access in that experiment is if I gave the paper that I used to plagiarize. So I'm already telling the model, is this paper plagiarized from this paper? That's the experiment that's referring to Oracle access. That is even not 100%. Even that's not 100% because the models are quite good at rephrasing. Yes. Yeah. That's all. Like that's a good point. Even that's not 100%. Yeah. Right. So you might get lucky, but you should not rely on luck. One approach is like, okay, like if you are a model developer, just store all the responses. Like I can maybe request OpenAI, Gemini to just like whatever conversations are happening with that model, can you please store it, and can you please give access, a query access to educators like me, so that I can figure out whether my students are actually learning stuff, right? So is this a good idea, bad idea? So bad idea, one reason it's maybe a lot of data, but storage is cheap, so possible. Privacy, yes. So if I knew all my conversations are being stored and are maybe one hack away from being public, I would be very worried, right? And companies would be very worried in letting their employees use these systems because again, like these systems are storing them, right? You could store a hash of it, but I guess then the person using it would just have to rearrange text. That's right. So that's a good point. You could potentially encrypt and hash it, but the person, if they change one word or make a slight adjustment, or then it won't match, right? Yeah. So the other concern is it won't work for open source models, right? It will only work for models who, which are being maintained by someone else. So if you really want to cheat assignments due tomorrow, you'll download Llama and just do it yourself, right? Locally. It might save it on your disk, but who cares, right? So wouldn't work for open source, the privacy concerns, and as I mentioned, like even if there's one word change, it won't match if I'm doing an exact match. So one of the ways that people have come up to deal with this problem is called watermarking. Someone suggested here as well. And this is an idea a few centuries old. We have been watermarking a lot of stuff. So currency notes are watermarked. So you might be able to see a Gandhiji on your currency note. Transcripts are watermarked. So we want something like this, but for text, right? So if I am able to add some signal that I can later detect that this is indeed from my model, that would be amazing, right? So there's this amazing paper by John and from Tom Goldstein's group in general, which also got the best paper at ICML a couple of years ago. So they propose a ridiculously simple technique to watermark language models. So let me run that here. So let's say you have a language model. Language models tell you what words come next. They assign probabilities. So let's say I work at Indian Institute of Science. I live in. So the model is a good one. Let's say it assigns a high probability to Bangalore, low probability to Chicago, Seattle, and so on. And now I want to watermark this model. I want to watermark the outputs of this model. So one approach could be that based on the last token, like in, let me partition the vocabulary into two halves. Let's say 75% of all vocabulary words go into a green list randomly, and 25% of them go in red list. So here there are 8 words, 6 of them go in the green list, 2 of them go in the red list. And now the strategy of generation is that I never generate a word from the red list. I only generate words from the green list, right? So if I am using a language model, then all my words will come from a green list because of this choice I've made, right? But if you don't know anything about the language model and you are a sincere student writing and doing your own homework, you will just on expectation generate 25% red list words, right? So in your writing, I'll see a lot of red list words, but in LLM writing, I will see a lot more green list words, or in fact, 100% of the green list words. So even if a student changed 3-4 words, it will still predominantly be green list. So I will still be able to catch those people who just change few words here and there. Because this is again like the model is just largely generating only green words. So is there a problem here, like, or this is good? So one reason is like, okay, why do we need to contextualize on in? Like when we are generating randomly, we are partitioning the vocabulary into 2 lists. Why am I suggesting that you condition on the previous word? One reason is that you want to ideally also do detection. So you need to, these are random lists, so you should be able to also recreate these lists if you're doing the testing, right? So if later I want to test whether your homework is AI generated or not, I should be able to run this algorithm, figure out the green list and red list exactly like I would have had I been generating this text, right? So I need some anchors to like have as seeds for my partitioning. So what if this, like, by the way, yeah, the detection is very simple, right? If words are from the green list, then we know it's from a model. So what happens if the word Bangalore is in the red list? Can that happen? Yes, it can happen, right? Like it's random. So in that case, I will not be able to live in Bangalore, right? And let's say if Obama is in the red list of Barack, then poor guy's name can never be generated by a model, right? So this is a concern, right? Like Barack Obama will never be generated if Obama just randomly happens to be in the red list of red list of Barack. And that's a 25% chance, right? If I'm choosing 25% partition for red lists. So this seems like a big problem. But it can be fixed with a small change. So instead of being very strict about never generating from red list, we make a slight change. We say that boost green words. So give some preferential treatment to green words. add some delta to their probabilities, leave red words as it is. So if a red word had a very high probability, it will still be generated. So Barack Obama would still be written because Obama is very, very likely to come after Barack. But some words that you only know, that are secretly kept with you, are preferred in LLM writing. Right? So this is the trap that watermarking sets. Some subset of words at every given point of time are slightly more preferred and you don't know which ones. So if you're actually doing the homework by yourself, you don't even have to care. You will have about 75% green words, 25% red words. But if someone took everything from an LLM, they will have a lot more than 75% green words. They'll have some red words, but more than 75%. So now this approach is called soft watermarking because it's softer here, not yeah. Yeah, that's a hyperparameter. You can actually choose that. Yeah, 75 is just this an example. Yeah, yeah.
The student is good, but he, for example, the threshold is 75, but he does like 98% of green watermarks.
Yeah, so that's actually very, very rare, statistically extremely rare. And again, if it is 10 word, 15 words, then it can actually happen. Which is why the general recommendation is never decide anything based on a short piece of text. You need at least 50, 100 words to be able to make a assessment of whether it came from a model or not. All right. Any more questions, sir? Yeah.
You will never write an exam furthermore.
Yeah. So there are definitely cues even for AI writing. There are a lot of cues like things like delve, imperative. Yeah, I mean, but that by itself can't be a strategy, even though it's a big hint. Yeah, that's true. Yeah. Yeah. And there are also like meta aspects about it, right? Like you talked to the student, you know, like how they communicate, and all of a sudden their English is at a Shashi Tharoor level, right? So you immediately realize, right, something's off. Humanize it, yeah. Yeah. So in this case, yeah, so it really depends how drastically a different service like humanize changes the text. If it only makes, let's say, 2, 3, 4, 5, 10 words changes, then it will still be detected. But if it almost made it look like new text, then watermarking will be scrubbed off. Right? Any more questions? Yeah.
Do you know how much LLM has the capability of
Humanizing, how much LLM has the capability?
It can humanize so that others don't detect it.
Right. So if you are using the same LLM to humanize, by the way, for people who don't know humanize, there is this like new tool that you generate, like, so that this is what students do now. Like this is a recipe, like generate from GPT. The chances people will catch it. There's a website called Humanize AI. Notice the irony with the name Humanize AI, right? And you go there, you submit the same text. It gives you slightly different text, but that's safer to submit, right? So if you're using the same LLM for humanizing, then this watermarking logic still applies, right? So if you use the same LLM, then you're still gonna get caught, right? Say that again. So the model developer creates this watermark. It's like a trap that they set.
They have to agree.
They have to agree. So that's a big requirement, and I'll come to that. Yeah. Yeah. So yeah, they have their own red list, and yeah. So ideally, the way it could have actually moved is, let's say, educators or journalists get a service which runs it through 5 or 10 different providers watermarking services and checks whether it matches with any of that. right? So it would have to do that for multiple providers. Yeah. Yeah, you could potentially get away with like one para here, another here, another here. Yeah, but that's a lot of work. People don't want to do that much work. Okay, so here the testing works a little bit differently now. Not all words are green words, but a large fraction, larger than what we would randomly expect, are from green words. And we can suspect if there is a large fraction, and we can actually run a statistical test. I won't go into the mathematical detail of how statistical tests work in this case, but you can imagine how, like, people who are familiar with it, you can imagine how you can run a test to check this. So there's sort of like few useful properties on watermarking. One of them is it can be applied to any language model. It does not matter whether it's an RNN, Transformer, OpenAI, Gemini. All I care about is final layer probabilities, and I just change that a little bit. And there are knobs to play with the strength, like how much delta you add, what is my partition. So you can up down the strength of the watermarking. And it's also very conceptually simple. And this is, again, I didn't go into the details of how detection works, but it does not actually require you to have the model probabilities. It just requires you to have the green list and red list. So if someone actually supplied a magical prompt or their own prompt, you don't have to know that prompt. You just have to, even if something is copied from the middle, you will be able to run the test. Okay. And it basically works, right? Like even with 30 tokens, you are able to get a false positive rate of 3 into 10 to the power minus 5. So watermarking is a feasible solution, I think, right? And we have done a lot of work on watermarking, understanding things like, how does it impact the performance? Are we making the models bad because we're watermarking them? Can it be hacked? Can I sniff the green list, red list by looking at patterns in the data? That is somewhat possible. And then we use some ideas of watermarking to watermark your content as well. So if you were to release a paper or a data set that you don't want models to pre-train on, and you should have some signal that you can later use and say that, look, you trained on my data. So you can use a watermarking based solution to stamp your work. So this is a paper just came out ICML this year. So we've done a lot of work and we were very excited about watermarking in general. And this seems like mathematically sound, principled, but in practice, there is almost no adoption. In 2023, all major companies, including Amazon, Anthropic, OpenAI, Google, Meta, or Facebook, I don't know what it was called back then, all of them agreed in a White House executive order that they're going to watermark. It was a promise that immediately changed with the administration, right? So that promise is no longer being kept. And so there is almost no adoption. Like, can you think why? Business, that's great. Yeah, like corporations are worried that they'll lose customers, right? If you know that whatever you're using ChatGPT for could later be used to catch you, like people will go to a different provider. And even if there is one provider who's of similar quality that's not watermarked, people will just rush to that provider. So this has to be like a concerted effort done collectively and has to be regulated. Without it, it won't happen. Policy. It has to be policy, yes. Policy and enforcement, yes. Yeah. They are not, if they're using it within guidelines, yeah, you don't care. That's right. Yeah. So that's actually a good point. Like, I think maybe the tone of my talk is more like everyone's just trying to scam the system. There are a lot of legitimate use cases for LLMs. So in fact, like some people at OpenAI also argue that, watermarking will hurt non-native speakers. So people who are genuinely benefiting in stating their ideas more articulately, why are you after those kids? Like, why are you catching them? Like, it is a beneficial tool that you should just let people use without detection. So there are, like, I think, good arguments to be made of not watermarking, but largely, in my opinion, I think it's business at the end of the day.
is open source, then can customers see the lists as well?
Yeah. So if the model is open source, by the way, none of this works for open source models, right? So you can just comment out the line that adds the delta probability to the green list, and you can just unwatermark a model. So in fact, like one of my PhD student actually is developing or has developed a method that can take the watermarking logic and incorporate that in the weights of the model. So the model operates in a similar way, but that is due to the weights of the model rather than this decoding logic. So the same kind of behavior is mimicked by the weights of the model, right? So in practice, at least watermarking has seen no adoption. Only Gemini is watermarked, and even for Gemini, I don't think the service is available so far, right? Like I can't check whether this is written by Gemini or not, for instance. And I think there are also no plans for watermarking for a lot of players. So in practice, again, like this is an important business problem, right? I would pay money to be able to get good quality detection. So there are like tons of private services, like 20 USD a month, you can go subscribe and get some kind of detection. These are like proprietary tools. Some of them have released their tech reports on how they do that. I think Pangram, I've had quite a lot of success using. Their detection rates are very good, and they are big believers in Sutton's bitter lesson. So they have literally taken billions of human written articles, generated similar AI written articles, and trained a giant transformer to do the detection. And it surprisingly works. Because there are indeed a lot of patterns in AI writing, things like imperative, delve, conclusions will always be there. It will always have bullets. Every bullet will start with a bold summary of the bullet. So there are lots of these patterns that these models are exploiting, and they work with varying effectiveness. So that's the whole story about how we diagnosed AI slop in research and some of our efforts to detect AI slop, and it's like work in progress. We don't know how this will shape up, and I'm happy to take questions. Yeah.
If we use the ASCII characters, mostly ASCII character, or maybe it can be hidden ASCII characters also, which actually RNA will generate those ASCII character, and that would be a watermark of that model.
Yeah.
So, like, what are the problems can be there for?
Yeah. So there are like some very weird strategies that. Yeah. So there are some hacks to get rid of watermarking. You might say, like, I want an essay about networking, or I want to generate a summary of this paper, but after every word, add a smiley. And later you Control F and delete that smiley. Because the green lists rely on the past previous word to decide which way to partition, you have essentially killed that signal. All right. So there are like some hacks around it, but I think these are easily detectable. Like if someone is trying to do that, I can potentially diagnose that you are trying to cheat the watermarking system. So it's not that big of a concern.
But would it change the response as well? Because
Yeah, it will change the quality of the response as well. Yeah, it won't be as good. Yeah. So by the way, there have been some studies also on like what happens if we start paraphrasing, changing one word, two word, three word, and the consensus is that you need to change about 60 to 70% of the words to not be detected. So at that point of time, you might as well do your homework, right? If you're changing 60, 70% of the content.
Even more tough.
I think, yeah, maybe that's even more tough. Yeah. Cool. Any more questions? Yeah.
Like they take prompts from or give the same prompt to all the base services, like all the Gemini and ChatGPT. Then I get the response, and then over that I will build up the again another paragraph. suppose that kind of service is there, which is like kind of automating what we are doing right. So then how much difficult it becomes to detect this is the AI generated part.
Right. So if the final output came from some model, even if the initial prompt came from multiple other models, then the watermarking will apply. But if it is the case that you choose one line from DeepSeek, one from Gemini, one from OpenAI, then it will be like the watermarking strength of each of them will be diluted.
Unless they all show the same.
Unless they all collectively choose the same lists. Yeah. Yeah, question.
Can you write watermarking by putting the text to a translator?
Yeah. So that's another cheat code, right? You take AI output, go to Google Translate, say translate it in Hindi, then ask the same model translate it back to English, and that might not have that kind of watermark, but it also may, like, it depends on how drastically is it changing the original text. So if the translation is only changing a small percentage of what you originally had, then the watermarking is still going to be intact, but it will dilute it. Yeah.
But the translates are the generated, not the LLM.
Yeah, that also depends. So if Google Translate is itself watermarked, then you might be caught there, for instance. Yeah. So I think it will be able to like if you change 50 to 60% of the words, then you won't be detected.
So is this the only way to watermark?
No. There are other ways to watermark as well. Yeah.
Because I heard somewhere that they use some invisible text inside.
Okay. So those methods exist that I will maybe add one small smiley in white font somewhere if that is present. I think those are not very robust watermarks. They can be, like, if I have that knowledge, I can just delete that. Yeah. I think they are not as strong as these kinds of watermarks.
What if I spend many more time with LLM models
Hmm.
and start the English, like I'm a village guy, so I'm not good in
Sure.
English that
Yeah.
much. So with chatting with the LLM models,
Yeah.
I learn the English.
Yeah.
So definitely after a certain time, my English will be something like
Some version of LLM, right? Yeah. So if
original content writing can be
right. So the false positives, like you're saying, like I did the work, but I learned English through an LLM. Will I be caught forever? The answer is no, because like this really requires. It's not based on like maybe you're using words that LLM uses, like evolve or delve, things like that. But watermarking is very strict. It will figure out at every point of time whether it's green or red. But you, when you're writing, you don't have that list in mind, right? You are just writing based on whatever English you've learned. Yeah, you might be randomly using it, but your patterns will not exactly match these. Yeah. You might be detected by some of these. Like it depends on how sincerely you have obeyed GPT's tutorials. So some of these might still catch you. Yeah. So images is a different ball game. This is only for text here.
is the red and green list are conditioned. They are conditioned.
They're conditioned on the past word so that you can also generate it yourself, right? You need to know, you need to have a recipe to generate the same list.
Like the computer code we generate. So there also, like, because some people feel like someone has read our code and is generating our code that somewhere we have patented.
Right. So same goes for code, right? Like code also will, like same watermarking can apply for code models also. Because there also you might encourage a few tokens to be generated more prominently than others. Code also, by the way, has comments, right?
Thank you, Professor, for accepting our request and delivering such an interesting talk. Thanks everyone for attending. We have arranged refreshments in the coffee hut. Please continue your conversations there.